This video is just going to be a review of everything you learned so far about work, and with this video you should be able to answer all the questions on number 1 through 10 and 18 through 21 on page 215 of your textbook. So, and you really don't even need the video, but this will just help you out. So the first question will ask about the work equation. The work is equal to force times displacement times the cosine of theta. Force is the component that's parallel to the direction of the displacement, hence that is why we would use the cosine, because the cosine is adjacent and it would be the cosine component that will be parallel. The units of work are the joules, and they're derived from Newton meters, right? Force times displacement is newtons and meters, so combined that makes joules. Work is also scalar, so only the magnitude of force and the magnitude of displacement are actually what you're using when you solve for work. Mechanical work, work is mechanical work done on a force, by a force on a system. We don't really need this slide. This is a repeat slide. Okay. Work can be positive or negative. Move this back a little bit so you can see that. All right, how do you know if it's positive or negative? It is positive. Work is positive when the parallel component of force is in the same direction as the displacement. And then, of course, it's negative when the parallel component of force is in the opposite direction. So just as a reminder, positive, the degrees are 0 to 90, not including 90, and negative 90 to 180, not including 90, because 90 would be pushing straight down and zero work would get done. So when is zero work? Can there be zero work? Yes. If a force is applied that cannot overcome the opposing force, basically no displacement is occurring, such as the sled rocket. If you're applying a thrust and it's less than or equal to friction, there's no displacement, even though force is applied. There's kind of an equilibrium there, and no work is getting done. And also, if the force applied is perpendicular to the motion, there's no parallel component at all, such as a dog being pulled by gravity. He's pulled down by gravity, but he's just running forward. Okay, he's not lifted up or jumping down. He's just going straight. Then gravity is not doing any work on the dog. All right, what does the work graph look like? It's a force displacement graph, and of course the area under the curve is what will represent work. Hooke's law. Hooke's law has to do with springs, because when the force increases as you pull on the spring, the displacement also increases. And right now we have a positive slope because we're talking about the force being applied to the spring. When does Hooke's law apply? Well, Hooke's law applies to ideal springs, and the springs need to or must be able to be compressed and stretched with the same magnitude of force to obey this law. So rubber bands don't really count. They don't really obey Hooke's law because you cannot compress them. But if a spring is ideal, like many ideal things in physics, you can stretch it and you can compress it the same displacement, the same magnitude, and that would require the same force. Gravitational work. Gravity is the constant force near the surface of the earth. So the only variable that affects its work is a change in vertical position, such as a ball dropping to the ground or a person lifting a TV. So unless there's displacement occurring up or down, then gravity is not doing any work. Power. Power is the rate that work is accomplished. Average power formula. there's two formulas. Average power equals work over the change in time. The force times the displacement times the cosine of theta over time. So the same thing there. All right. Or the force times the velocity times the cosine of theta. If you don't have that second formula written down, you may want to write that down. Displacement over time is velocity, so force times velocity is also power. All right, so that should be plenty of information. Oh, power scalar. That should be all the information you need to answer those questions. So if you have any other concerns, feel free to let me know.